Hi children, I am Sagar, a mathematics faculty, have been 11 years of experience in teaching. Today we are going to discuss about functions. Before going to function, first we have to discuss about the definition of the function. What is the definition of the function? See this one. If A comma B are non-empty sets, then the relation f from A to B is said to be a function if every element of A has unit image in B. Should keep in mind this one. This is very, very important. If every element of A has a unit image in B. Understood now? A, B are two non-empty sets. What is the meaning of non-empty sets? The two sets should contain minimum one element. That's why A and B are called non-empty sets. Therefore, non-empty sets, the relation from A to B is said to be a function if every element of A has unique image in B. You should mark every element in A. Let us take A is one set and B is one more set. This A contain the elements 1, 2, 3. B contain A, B, C, D. This mapping from A to B in the function f. See, I will mapping. 1 is mapping with 2. See, 2 is mapping with A and 3 is mapping with B. Is it function or not? It is absolutely a function because each and every element in A, all elements in A are mapping, and these elements has unique image in B. It is a function. Let's see. This is 1, 2, 3 and A, B, C, D. A, B. One is mapping with B and also one is mapping with C. 2 is mapping with A, 3 is mapping with B. Is it function? It is mapping only. It is not a function because one has two images. One is mapping with B and one is mapping with C. So one has two images. That's why it is not a function. It is not a function. This is mapping only. Next, see this one. 1, 2, 3, 5, 6, 7, 8. A set contain 1, 2, 3 and B set contain 5, 6, 7, 8. 1 is mapping with 6, 2 is mapping with 6, 3 also mapping with 6. Is it function or not? One check the definition. What is the definition of the function? If every element of A, that means in the set A, all the elements are mapping here. And also one more condition there, it has unique images. One has how many images? Only one image. 2 also has only one image. 3 also has only one image. That's why it is a function. It is a function. So this is the definition of the function. Is it clear now? This is the definition of the function. That is, for x belongs to A, X is an element in the X is an element in the set A. They register a unit Y belongs to B, such that f of x is equals to y. So this is the definition of the function. Now come to domain, codomain and range. Domain. F from A to B is a function. F is mapping from A to B. Here A is called domain. A is called domain. B is called codomain. B is called codomain. See, set A and set B are the two non-empty sets. 1, 2, 3. Here A, B, C, D. This is the function with F. 1 is mapping with B, 2 is mapping with A, 3 is mapping with D. It is a function. And here, what is the domain in this function? 1, 2, 3. A is the domain. Set of all elements in a set A is called domain. So here domain 1, 2, 3. Codomain is nothing but set B is the codomain. Which elements are there in the codomain? A, B, C, D. These all are the codomains. And the range. Range is nothing but which elements are assigned in the set B. Which elements are assigned, that means which elements are mapping in the set B is called range. Which elements are mapping in the codomain? B, A, D. These three elements only are mapped in the set B. So here range is nothing but A, B, D. Range is the subset of codomain. Range is the subset of codomain. Is it clear, Mark? Domain, codomain and range. Domain is nothing but set of all elements in the set A. First set is called domain and the second set, that means B, here B is called codomain. Range is nothing but which elements are mapping or assigned in the set B. Those elements are called range. Okay? I will give some examples. See here 5, 6, 7, 8, 3, 2, 1, 9, 18. 5 is mapping with 2, 6 is mapping with 3, 7 is mapping with 1, 8 is mapping with 1. First of all, we have to check is it function or not. Absolutely it is a function because in the set A all elements are mapping and it has unique images. All elements are having unique images. That's why it is a function. And what is the domain here? Domain is set A, that is set of 5, 6, 7, 8. Range, codomain. Codomain is nothing but set B, the set of 3, 2, 1, 9. These all are the codomains. Now coming to range. Range is nothing but which elements are mapping or assigned in the set B. Which elements are mapping in the set B? 3, 2, 1 only. So range is nothing but 3, 2, 1. This is about the domain, codomain and range. This is the very important topic in the intermediate. Okay? Domain, codomain and range. Next come to types of functions. Types of functions. The first function is one function or injection. One function or injection. What is the definition of one function? If you are from A to B, is said to be one function. Is said to be one function or injection. One function or injection. If A elements in A has different images. If different elements in A has different images, in B, from A to B set to B, one function or injection. If different elements in A has different images in B, in this condition only f is called one function. And see here, 1, 2, 3, 5, 6, 7, 8. A contain 1, 2, 3. B contain 5, 6, 7, 8. 1 is mapping with 6. 3 is mapping with 5. 3 is mapping with 8. First, you have to check, is it function or not? It is a function. And what is the definition of one function? Different elements in A has different images. One check. What is the image of 1? 6. What is the image of 2? 5. What is the image of 3? 8. Different elements has different images. That's why it is one function. Now check A and B. A contain A, B, C, and B contain 2, 3, 5, 6, mapping G. A mapping with 3, B is mapping with 2, C is mapping with 3. So first we have to check, it is a function or not. Is it function or not? Yes, it is a function. Is it onto one function? No, because A and C has same images. The image of A is 3, the image of C also 3. That's why it is not one function. It is not one function. We'll check one more example. Set A and set B. There is 1, 2, 3, this A, B, C. Okay. One is mapping with B, 2 is mapping with A. Is it one function? Observe. Is it first of all, it is a function or not? It is not a function because 3 is not assigned to any element in the set B. So it is not a function. First of all, it is not a function. That's why it is not one function. Okay? This is the definition of one function. This is the definition of one function. The next one is onto function. Onto function. Onto function. If f from A to B, f from A to B is said to be a onto, if f of A is equals to B. F of A. What is the meaning of f of A? The meaning of f of A is nothing but the image of f. The image of f. This is the condition for onto. All the images of f is equals to the codomain. All the images of f is equals to the codomain. The meaning of that one is in the codomain all elements should mapping. The codomain all elements should mapping. In this condition only, the function is called onto function. See, 1, 2, 3, 5, 6. AB. See, 1 is mapping with 6, 2 is mapping with 5, 3 is mapping with 6. First of all, I have to check the given function is, the given relation is function or not. function, it is onto or not. One check which elements are there in the codomain 5, 6. These two are mapping. That's why it is called a onto function. 1, 2, 3, 5, 6, 7. Set A and set B. 1 is mapping with 6, 2 is mapping with 5, 3 is mapping with 5. Is it onto function or not? No, it is not an onto function because here in the codomain 7 is not mapping with any element from A. So it is not onto. It is not onto function. See? AB. A is mapping with 5, B is also mapping with 5, C also mapping with 5. Is it onto function? Yes, it is absolutely onto function because all the elements in the set B are mapping. That's why it is onto function. Okay? One more name for onto function is subjection. One more name for onto function is subjection. Next, one more. Bijection. If you are from A to B, is said to be a bijection. Is said to be a bijection. It satisfies both 1, 1 and onto. In this case only, if any function is satisfied 1, 1 and onto, then that function is called bijection. That function is called bijection. Let's see the example. 1, 2, 3, A, B, C. One is mapping with B, 2 is mapping with C, 3 is mapping with A. Is it bijection or not? Once observe. Here, the two, this function satisfy both 1, 1 and onto. Check. What is the definition of 1, 1? Different elements of A has different images in B. If that condition is satisfied, so it is 1, 1 function. What about onto? Onto is nothing but the codomain is equals to the range. Codomain is equals to the range. Here that condition also satisfies. That's why it is bijection. Next, see one more example. A, B. Set A contains A, B, C. Set B contains 1, 2, 3, 4. A is mapping with 4, B is mapping with 3, and C is mapping with 1. Is it bijection or not? One check. First of all, we have to check it is 1, 1 or not. Yes, it is 1, 1 function because set A contains different images. All elements the set A contains different images in B. So that's why it is 1, 1 function. But it is not onto. But it is not onto. Because range is not equals to the codomain. Range is not equals to codomain. What is the range of this function? 1, 3, 4. Codomain is nothing but 1, 2, 3, 4. So it is only 1, 1 function. It is only 1, 1 function, but it is not a bijection. But it is not a bijection. Is it clear now? The next one is constant function. The next one is constant function. If f from A to B is said to be a constant function, is said to be a constant function, same element and y belongs to B is a sign all the elements in X belongs to B. What is the meaning of this one? All the elements in the set A should map with only one element in the set B. Means here A and B. A, B, C, D, 3, 4, 5. Here A is mapping with 4, B is mapping with 4, C also mapping with 4, D also mapping with 4. All the elements in the set A should map with only one element in the set B. In this case only, the function is called constant function. Simple definition is range is constant. Range is constant. F of A, the range of A is nothing but 4. The range of B also 4. The range of C is also a 4. Range of D is also a 4. Range is constant is called constant function. Next one is identity function. Identity function. If you are from A to A, is an identity function. Is an identity function. If every element of A has same image, the image of the simple definition that the image of an element is itself. That means I of x is equal to x. The image of x is equal to x. It is called a identity function. It is denoted with I from A to A. I is identity function. It maps from A to A. Now see here, A is a set and second set also A. A contain 1, 2, 3, 1, 2, 3. The image of 1 is nothing but 1, 2 is mapped with 2, 3 is mapped with 3. So it is called identity function. If an element contains same image, The image of one element is itself. It is called identity function. Okay. See the next one. Even function. Even function. If f from A to R is defined an even function, if f of minus x is equal to f of x, f of minus x is equal to f of x, then it is called an even function. See, f of x is equal to cos x. If f of x is equal to cos x, is it even function or odd function? Let us take f of minus x is equals to cos of minus x. We know the value of cos of minus theta. Cos of minus theta is nothing but cos theta. Okay? That is equals to cos x. It is equals to f of x. So f of minus x is equals to f of x. F of minus x is equal to f of x. So cos x is called even function. And one more condition there, f of minus x minus f of x equal to 0. This is also one more condition for the even function. F of minus x minus of f of x equal to 0. The next definition is odd function. Odd function. If f from A to B, if f from A to B is said to be an odd function, f of minus x is equal to minus f of x. F of minus x equal to minus f of x. See, let us take f of x equal to sin x. Once observe, is it even function or odd function? I have to check this condition only. F of minus x is equals to sin of minus x. Sin of minus x is nothing but minus sin x. So it is minus f of x. So f of minus x is equals to minus f of x. So sin x is an odd function. One more condition for odd function is f of minus x plus f of x equal to 0. F of minus x plus f of x equal to 0. This is the condition for odd function. These are the types of the functions.